Good morning everyone, welcome. Alright guys, very good morning. So we are going to continue our discussion on stereochemistry, but today we are not doing dynamic stereochemistry. We are going to do the stereochemistry revision, that is the RNS configuration. So majorly we are going to focus on RS configuration, then what is the relationship between different molecules, isomers, right? That is, let's say these two molecules are diastereomers, enantiomer, homomers, like that, and also on the topicity. So these three topics we are going to revise in today's session, and we are also going to do the question practice for the same. All right. Yes. So I just hope that all of you can hear me properly. Yes, very good morning, all of you. Very good morning. Okay, so as I've written over here, we are going to do the revision and on all of these topics, and then we'll solve some really good questions. Okay, so chalo, let's start. Yes, everyone is able to see and hear properly. Very good. So before moving onwards, guys, as you already know कि अभी जो Unacademy Unlock सब्सक्रिप्शन का ऑफर चल रहा है, that is 20% off on using the same code Jagriti S Live. All right, and this offer is valid till 26th of August from 22nd. ठीक है, so you can subscribe within this time frame to get 20% discount on both the Unacademy Plus and Iconic subscriptions, where you have a lot of benefits. And also guys, one more important benefit is that जो ऐप है अनअकैडमी का, वहां पे आपको क्या मिल रहे हैं, नोट्स. Okay, so the in-app notes will be available from 24th of August, that is from today itself. The notes will be available to you. All right, keep on checking. Or the update has already been made, guys. So to the plus students as well as the iconic students, जो ऐप के अंदर नोट्स है सारे चैप्टर के, वो आपको मिल जाएंगे. So you will be able to access the notes, right? And also guys, the detailed and practice batch, both of these batches are also going on. So yes, please go through the course pages on the Unacademy Plus platform, and you can see all the classes which are added in the courses, right? Yes, और आपको अगर ज्वाइन करना है टेलीग्राम ग्रुप फॉर रेगुलर नोटिफिकेशन, देन यू कैन सर्च फॉर CSIR NET 2022. यहाँ पे आप ज्वाइन कर सकते हो. Yes, all right. Yes, Mohit, I'm good. Thank you for asking. Good morning to all of you. Okay, so first thing, guys, what are we going to discuss? We are going to do the revision of the RNS configuration. ठीक है, and along with that, finding out the relationship between two molecules. ठीक है, एकदम बेसिक स्टीरियोकेमिस्ट्री, बट बेसिक में भी कभी कभार डिफिकल्ट क्वेश्चंस आ जाते हैं. So we will try to see all of them one by one. Yes, isn't it? Chalo. So let's try to find out the RNS configuration of a molecule. I hope that you already know the rules. Yes, you do. तो फिर इस मॉलिक्यूल का जो है RS configuration हमें find out करना है. Okay, this one. Yes, guys, what is the first one, R or S? Very good morning, all of you. S. चलो देखते हैं. So let's give the priority order. First priority order to the carbon which is connected to the oxygen, since all of these are carbons only. तो इसको हम देखेंगे सबसे पहले. Connected to oxygen. This carbon is connected to plenty of other carbons, but the first point of difference will be when this carbon got connected to oxygen having a heavier atomic number or a greater atomic number than another carbon. तो ये हो गया second. Third priority is the methyl. Fourth priority hydrogen. अब ये देखो, where is the hydrogen? Fourth priority, it is already below the plane, तो very good, below the plane है. So whatever is the rotation, that is exactly going to give you the configuration. Anti-clockwise means S. Yes. What about the second one, guys? What about the second one? What is the priority order? One, two, 3 and 4. So once again what happens over here, least priority is below the plane. Very well. So 1, 2, 3 will become anti-clockwise. So ये भी क्या है? S configuration है. Alright. Very well. So we will do more examples like these. Let's look at this cyclic molecule. Yes. What is the RNS nomenclature of this particular molecule? Alright, so let's see the priority order, guys. So first priority order is going to go to this OH, right? First one. Second, हम जाएंगे आगे बढ़ेंगे in the chain, right? So we see there is also CH2. This is also CH2. This is a CH2. However, this is C double bond O. Second priority over here, third over here, and fourth priority group is already below the plane. So 1, 2, 3 is clockwise, and that is why it's going to give you R configuration. Very good. Yes, चलो एक और देखते हैं guys. When in the same molecule we are having two chiral centers. In the same molecules we are having two chiral centers. So guys, क्या ये necessary condition है कि अगर एक molecule में दो chiral center हो गए तो वो molecule chiral होगा? Is it necessary that in the same molecule if we are having two chiral centers the molecule will be chiral? Yes guys, is this condition necessary? Two or more than two chiral centers. Yeah, there could be a plane of symmetry, center of symmetry, anything, right? Yes, plane of symmetry भी हो सकता है. Yes, right? Not necessary. Very good. Alright, so what about this? There are two chiral centers over here. But यहाँ तो कुछ भी नहीं है. No plane of symmetry, nothing. So we can say this is chiral. Yes, all right. So let's check, guys. First carbon है, right? So on this first carbon, the priority order is going to be first one for this. ठीक है? अच्छा. First for this, second इसके लिए नहीं बोलेंगे. Second will be for this one. Why? Because this is connected to three carbons, right? And third for this, fourth priority to the methyl. So ये देखो क्या है, guys? 1, 2, 3 is anti-clockwise, but fourth priority group is above. तो हम इसको लिख देंगे R. This first one, this one is going to be R. Yes. What about the next one? Let's give the priority order on this side, guys. So looking at this carbon, और हम blue pen से इसको color करते हैं so that we can differentiate. So this carbon over here, this is going to have first priority over here. Why? It is connected to four different carbons, right? Second priority moving in this side, in this chain we are going to have second priority क्योंकि यहाँ पे carbonyl है. Third priority moving in this chain. Fourth priority hydrogen is below the plane already. So ये क्या हो गया? 1, 2, 3 anti-clockwise. That is going to be S. All right? Yes. So R and S are absolutely correct. तो एक काम और करते हैं. Let's now do the RNS nomenclature of this particular molecule. Let's say you have an a phenyl ring over here, and on this side you have COOMe. चलो epoxide के लिए करते हैं. Okay, so what do you think? If nothing is given, these are two different hydrogens. Yes. Good morning who are joining now. Yes, Sarita, welcome. Okay, so see, one by one we are going to give the priority order. तो पहले left hand side वाला carbon देखते हैं, guys. On this side, left hand side, right? So the first priority will be given to the oxygen atom which is directly connected to this carbon. Second priority, without any doubt, goes to this carbon which is connected to oxygen, isn't it? Third priority to the phenyl. So 1, 2, 3 is clockwise and your hydrogen is above the plane. So we have to write it S. We have to write it S over here, guys, क्योंकि ये clockwise rotation था और hydrogen above the plane आ गया है. So we have to write it S. Now writing the same molecule over here once again, but this time we will be taking the RNS of the second carbon. Okay, the molecule is the same. I'm just rewriting it. ठीक है, तो ये देखो इस कार्बन के लिए. So first priority to this oxygen, second priority could go to this carbon which is connected to an oxygen or to this carbon which is connected to two different oxygens. So second priority goes over here. Third priority goes over here and fourth is your hydrogen. So 1, 2, 3 is going to be clockwise. So this becomes R. Okay. Does it make sense? Yes or no? तो फिर आप इसका निकाल सकते हो. Yes. What is this? Is it the enantiomer of the previous epoxide? Yes, right? ये तो enantiomer है. So do we need to, हाँ, तो do we need to find out for each and every carbon? नहीं निकालना पड़ेगा. Why? Because अगर हमें मिल गया है that one enantiomer is SR, the mirror image is going to be RS. So this is going to be R and S. You can just confirm after finding it out. You'll get the same thing. ठीक है? 1, 2, 3 clockwise rotation और नीचे hydrogen है तो R ही आएगा, right? And 1, 2, 3 anti-clockwise going to give you S. Okay, so whenever we are getting two different enantiomer, you just have to find for one, the other one is going to be the opposite. Yes, all right. So shall I give you some questions कि what is the relationship between A and B type? अब question करते हैं guys. So what is the relationship between, okay, just 1 second, let me write over here. All right. So C2H5 bromine OH CH3HCl. This is molecule A and this is molecule B. Front carbon has OH hydrogen C2H5 CH3 Cl Br. So this is A and B. यस मोहित आप बताओ आईयूपीएससी करना है आपको. हेलो साध्वी. All right. See, we can find this by two ways. That is, one, writing the Fisher projection properly, right? मतलब पूरा इसको rotate करके convert करके proper लिखना है एकदम से, and then match what is going on. ठीक है? So एक तो वो कर सकते हैं. Second thing what we can do is we will see that if the bond connectivity is the same, what are the steps? सबसे पहले देखो bond connectivity. Is the bond connectivity same, guys? Tell me yes or no. What is bond connectivity? That is, to this one carbon, कौन connected है? Hydrogen C2H5OH, and on this, let's see, hydrogen C2H5OH. Yes, मतलब कि on the first carbon same groups are connected. On the back carbon, let's see who is connected. Chlorine CH3Br, chlorine CH3Br, ये भी ठीक है. So bond connectivity is same. जब bond connectivity same होती है then only we give rise to the stereoisomers. ठीक है? So now what we'll see is bond connectivity तो same है, so you can take them in any Fisher projection. तो मैं एक Fisher projection यहाँ लिखती हूँ for option number A. What I'll do is I'll just rotate. Let the first carbon be as it is, and the back carbon, let's say I'm putting the Cl over here, मैंने 120 डिग्री रोटेशन कर दिया. Cl इधर, Br इधर, और कौन नीचे चला जाएगा? CH3. Let's say I'm having this. So how is the Fisher projection going to look like? Fisher projection will look like this: CH3 Cl Br, okay, and और कौन है? H C2H5 OH. I can write this, isn't it? मैंने ये लिख दिया. Bond connectivity same है. Okay, what are you going to do? You can find out the RNS nomenclature of this one. You can find out the RNS nomenclature. So let's quickly do it, guys. So 1, 2, और ये third carbon OH से connected है, इसलिए 3 इसको देंगे. And then fourth is hydrogen. So vertical, and you are having anti-clockwise. Vertical anti-clockwise क्या आता है? S. ठीक है? And then give the priority on the second position. 1, इसको देंगे 2, 3 and 4. Horizontal है least priority group, so horizontal and clockwise is also going to be S. यस विष्णु, देखो वही मैं बता रही हूँ शॉर्टकट कि पहले तो बॉन्ड कनेक्टिविटी देख लो. इफ द बॉन्ड कनेक्टिविटी इज द सेम, टू द सेम कार्बन सेम नंबर ऑफ ग्रुप्स आर प्रेजेंट. अगर वो सेम है तो इस क्वेश्चन को जल्दी करने के लिए हम कोई मतलब नहीं है कि अल्काइल ग्रुप को वर्टिकल लाइन पे ले रहे हैं कि नहीं ले रहे हैं, और जल्दी करना है अगर हमें तो। अगर हम आराम से करना चाहते हैं तो ऑब्वियसली रिप्रेजेंटेशन वाइज इट्स गोइंग टू बी इजियर, लेकिन अगर हम जल्दी करना चाहते हैं तो जैसा ये मॉलिक्यूल है बस वैसे के वैसे इसको फिशर प्रोजेक्शन में देखो, और क्योंकि बॉन्ड कनेक्टिविटी सेम है तो हमें पता चल जाएगा। ठीक है, तो दिस वन इज एस एस, राइट। नाउ लेट्स लुक एट दिस वन, सेकेंड एग्जाम्पल देखते हैं। Let me just make some space. Look at the second example. See what do we see over here second example के अंदर, that is पहला कार्बन है उसके ऊपर CH3 टॉप में है, then this is Cl and then this is Br. The second carbon has OH over here, hydrogen, C2H5. Now automatically the alkyl groups are coming on the vertical line. मैंने ऐसे intentionally नहीं किया, right? So what I'll do is I'll just check the bond connectivity is the same. First carbon पे ये तीनों group है, यहाँ पे भी ये तीनों group है. Okay, very good. So once again do the priority. 1 2 3 4 same आएगा, anti-clockwise S. This is also coming out to be S. What about this one, guys? थोड़ा सा different है, but we will just find out the priority and according to the priority only we'll do the numbering. बस. So 1 2 3 is clockwise, horizontal clockwise is also S. So both of these are coming out to be S and S, which means what are they? They are homomers. ठीक है? They are homomers. तो मैंने क्या किया guys? To do this question fast, I will see bond connectivity कि एक कार्बन पे वही सेम ग्रुप्स होने चाहिए, अगर है तो उसको वैसे के वैसे फिशर प्रोजेक्शन में लिख दो, find out the R and S, and here these are homomers. Okay, we will do another similar question guys. Let's quickly change the slide if you all are done. आप न्यूमन से ही RNS देख लेते हो। अच्छा, मतलब सेम है या मतलब कि सुपर इम्पोजेबल है या नहीं वो देख लेते हो योगेश, इज इट? नो, इफ यू आर डूइंग इट इट इज एक्चुअली गुड, बट इसमें कभी कभार सिली मिस्टेक भी हो जाती है, सो इट्स ओके। व्हाट यू कैन डू इज Cl को इधर ले आओ, OH को इधर ले आओ, इफ यू आर हैविंग द सेम सुपर इम्पोजिबिलिटी, बस सुपर इम्पोजिबल है तो होमोमर है। चलो ठीक है, इफ यू वांट मी टू डिस्कस दैट पॉसिबिलिटी ऑल्सो, वो भी हम कर लेते हैं बहुत फटाफट से। फॉर द सेम yes, for the same example you have a Br over here and you have a CH3 over here. ठीक है, फर्स्ट वाला क्या था? You had this molecule. Okay, all right, so what are we going to do guys? OH and Cl are on the same side, alkyl groups are on the same side, तो हम वही करते हैं। let's rotate the CH3 over here. CH3 जो नीचे है उसको rotate कर दो, यहाँ ले आओ। Okay, and what will happen then? The Cl is also going to move, the Br is also going to move, और ये जो alkyl group है also bring it over here. So alkyl C2H5 comes over here, OH goes over here, hydrogen goes over here. So these two are absolutely superimposable. ठीक है, so this is also what you can do कि एक molecule को दूसरे molecule की तरह लिखना है same. So yes, by rotation also that you can see. Absolutely guys, two different methods, whichever you want to follow. हमें तो एग्जाम में सही करना है, whichever you like you can follow. Okay, now let's do this question. What is the relationship between P and Q? Same question. What is the relationship between P and Q? So I'm writing the P and Q over here. You can just follow whichever method you want to follow, और आपको सिर्फ सही आंसर देना है। So you are having OH, CH3 and cyanide in the back carbon. This is P. This is Q. All right. Yes. So we can do one more thing. जैसे ये Q molecule है where both the cyanides are opposite to each other. Okay. And here the cyanides are like this. तो क्या हम Q के जैसे लिख सकते हैं इसको? Yes. Let's write it in the same way. Below carbon cyanide I'm rotating, which means the CH3 is going to rotate and the OH is going to come over here. Something like this. ठीक है? And this cyanide I can write on this side. इसको मैंने rotate कर दिया. So if I'm rotating this cyanide flow over here, I'll see there's COH and NH2 group. So the bond connectivity is the same, isn't it? Bond connectivity is same type of groups are connected on same molecule. First वाला carbon जो है guys, you see first वाला carbon exactly same है. Yes, the first carbon is exactly superimposable, same. ठीक है? What happens to the next carbon? See, I am just taking the cyanide over here only, opposite to each other. तो मैंने ये देखा कि both the OH and CH3 are swapping their places. तो इससे क्या हो गया? Guys, when one carbon is same and the second carbon is different, इसको हम क्या बोलते हैं? This possibility is only there in diastereomers. So these two molecules are supposed to be diastereomers. Then only it is possible. Okay. Chalo. Let's do more questions of these type. Good morning, guys. Good morning. Who are joining now? Welcome. So, अब ऐसा question है. Which of the following statement regarding the projection is true? ठीक है? So there are two projections. Newman projection alright. So this is A and this is B. Two different projections. ठीक है? So first option is A and B are same molecules. Both A and B are optically active. B is optically active. और लास्ट में A is optically active. Which of the following statement regarding the projections is true? Yes, guys. So what are we going to do? ये staggered conformation है. Staggered conformation में all the groups are opposite. Even the methyl, they are 180 degrees. Cl, hydrogen, all of these are 180 degree. तो ये तो staggered conformation है ना. इसका eclipse लिखेंगे तो let's say the back carbon is as it is. ये बैक कार्बन जो है दिस इज एज इट इज CH3 ClH. वैसे ही मैंने फ्रंट कार्बन को रोटेट करके ले आई CH3. इफ इट रोटेट्स एग्जैक्टली ऑपोजिट दिस इज गोइंग टू बी Cl, दिस इज हाइड्रोजन. ये क्या बन गया गाइस? इट्स अ मेसो मॉलिक्यूल. Yes, it is a meso molecule. What about this one? You already have a CH3 on the same side and then you have both the H and Cl opposite. ये मॉलिक्यूल तो ऑप्टिकली एक्टिव है. क्यों? क्योंकि यहाँ पे एक C2 एक्सिस प्रेजेंट है. Isn't it? There is a C2 axis which is present over here. It is going to make the molecule dissymmetric. So B is optically active. ये सही है. And D is optically inactive. All right. Very very important question, guys. अब हम लोग आगे चलते हैं and we see more examples. All right. So the question is, indicate HA and HB are homotopic, enantiotopic, or diastereotopic. Alright, there are two molecules, so I'm writing respectively, okay? Homotopic, diastereotopic, enantiotopic, diastereotopic, diastereotopic, enantiotopic. Okay? So which one is the correct answer out of A, B, C, D for these two different molecules? This and this respectively. Yes. Option number B, is it? कैसे? यहाँ पे आपको क्या मिल गया guys? One C2 axis. Is this a C2 axis? Yes, it is. Also, there is a sigma plane. Alright, but we'll give more priority to the C2 axis. So it is going to be homotopic. What about this one? These two. Is there a sigma plane which is cutting the molecule into half? मतलब कि ये दोनों क्या होने चाहिए? Sigma plane reflectable. Isn't it? They must be reflected through the sigma plane. That is not possible, guys. क्योंकि ये वाला बॉन्ड तो अबव है और ये बॉन्ड तो बिलो है, so we must cut the molecule into half. वो नहीं कर सकते because there is no sigma pi bond over here. You cannot cut the molecule into half. मुझे पता है बहुत लोग बोलोगे मैम ऐसे काट दो इस molecule को, sideways कट कर दो, है ना, तब तो कट हो ही जाएगा. But then that way HA and HB will be themselves cut into half, right? And that is what we don't want. We want them to be sigma plane exchangeable. तो देर इज नो रिलेशनशिप, और ये हो गए डायस्टीरियोमर्स. ठीक है, हमें क्या करना है, इन दोनों को रिफ्लेक्ट करवाना है ना मिरर प्लेन से. अगर हम इसको ऐसे कट कर देंगे तो दे विल बी बाइसेक्टेड इनटू हाफ. सो बी इज द करेक्ट आंसर. ठीक है, नाउ लेट्स टेक सम मोर इम्पॉर्टेंट मॉलिक्यूल्स. What is the relationship between these two, HA and HB over here? Yes guys, इतना भी मुश्किल नहीं है. How do you bisect the cyclohexane? ये देखो, what I've written, I've made it easy for you. एक हाइड्रोजन above, एक below. You bisect the cyclohexane like this, isn't it? इस वाले cyclohexane को ऐसे you will divide it into half like this. Yes. तो अगर मैं यहाँ पे एक ग्रुप लगा दूं cyclohexane के ऊपर और यहाँ एक और ग्रुप है, फॉर एग्जाम्पल some random group, let's say R. So एक हाइड्रोजन बिलो और एक हाइड्रोजन अगर अबव होता है, so these two are going to be sigma plane exchangeable. Yes. एक बात सुनो मेरी, ये देखो, if I am having any kind of substituent on this carbon, R या CH2R बोलते हैं, let's call this CH2R. R group is going to be in the same plane like this. Both the hydrogens are going to be in this way. So there could be a sigma plane over here, right? ऐसे कर सकते हैं sigma plane से cut. So these two are going to be in anisotropic in this case. In anisotropic. In this particular molecule. What about the adamantine structure? Yes guys. Let's see. What about this structure? ओके, स्ट्रक्चर को एक बार दोबारा से बनाती हूँ मैं. अच्छा हाँ, देयर इज दिस वन ग्लिच ओवर हियर, सॉरी. ये देखो, दिस बॉन्ड इज गोइंग टू बी, ओके जस्ट अ सेकंड. Now you see it's going to be over here. ये यहाँ पे होता है, not over here, right? Now it will be able for easy for you to answer. Okay, now it's very easy for you to answer now, because now you can see कि ये देखो, if we are cutting through the cyclohexane in this way, if we are cutting in this way, हाँ, yes, now you see one methyl group, it is above, and this methylene group, it is below. So now you can cut the molecule into half. इस molecule को आप half में cut कर सकते हो, and both of these hydrogens will be sigma plane exchangeable. We write sigma plane exchangeable. Yes, then they will be enantiotopic. Yes, then they will be enantiotopic. ठीक है. Now also guys, in the same molecule sometimes you might get some substituent, तो वो भी देख लेते हैं यहाँ पे इधर. ठीक है. So let's say you are having a substituent on this side OH, and I'm still asking you about these two hydrogens. Is it still going to be an enantiotopic? You just have to say yes or no. Still an enantiotopic? No, Vishnu. ये जो देखो sigma plane है, that sigma plane can also cut the OH, guys. See, मैंने इस OH को कहाँ रखा है? On this one carbon, carbon number 1 over here. So if I'm saying that there is a sigma plane over here, the same sigma plane can also cut the OH into half. Isn't it? ये OH भी क्या हो जाएगा? Half में bisect हो जाएगा. It's going to be bisected into half, and both of these hydrogens will be reflected once again in enantiotopic only. ठीक है. OH is equatorial. अरे नहीं, इसका sigma plane हमें ऐसे नहीं देखना है. We don't need to see the sigma plane like this. हमें ऐसे cut करना है इसको. Okay? Which means we are cutting in between this carbon, in between this carbon, this carbon. इनको हम ऐसे कट कर रहे हैं. ठीक है. तो ये OH भी इक्वली हाफ में कट हो जाएगा, और ये दोनों हाइड्रोजन आगे और पीछे रिफ्लेक्ट हो जाएंगे. ठीक है. सो दिस इज स्टिल enantiotopic. ओके. Now if I'm writing something like this, let's say I am writing on this side as CH3. अब क्या होंगे ये दोनों ग्रुप्स? Absolutely diastereotopic. Absolutely. Why? Because एक तरफ मैंने क्या कर दिया? मिथाइल लगा दिया, and on the other side, on this carbon, it's just a methylene CH2. यहाँ तो नहीं है CH3. So no relationship. Yes, so these are going to be diastereotopic. So based on the substituent की substituent किधर है, then also you can tell that what is the answer going to be. Okay. So yes guys, अभी आज के लिए हम इतना ही पढ़ते हैं इस सेशन के अंदर, and we will continue the stereochemistry practice and discussion in the next session. Okay, and already informing you guys, please check the app for your updates and for the notes, and if they are available, also inform me once. और आपको पता ही है, Jagriti S Live is the code, referral code, and right now the 20% off ऑफर इज गोइंग ऑन टिल 26th of August. तो अगर किसी को ज्वाइन करना है तो प्लीज इस ऑफर में ही ज्वाइन करो, सो दैट यू हैव टू पे 20% लेस, बोथ फॉर प्लस एंड आइकॉनिक. ओके. All right, guys. So, yes, take care of yourself, and I'll see you very soon. 10:30. We have a plus class. All right. Bye, everyone.